All right, so something I wanted to talk about before we get to the next part of the lesson is the difference between different types of skew. All right, a skewed graph is not symmetric. It's where one side you see is much higher than the rest of it. So it sort of trails off here. It's almost like it's got a tail. Same with this one. So obviously these two graphs are both skewed, but they're skewed differently. So I want to talk about that type of skew. So positive skew means that wherever the skew is, the little tail, that's pointing in the positive direction. So if we look here, the skew is going off into the positive direction. Right? The skew also appears at the right side. For negative skew, when we follow the skew, follow the tail, we're going in the negative direction, right, to the left. And then exactly why it's called skewed left, because as it tails off, we're heading in the left direction. So I just wanted to make sure that was clear before we start. So these next few questions, they don't give you, but obviously it's a little bit different when we're not in the classroom. So what they're saying is they want us to add values to this data set and then see how that would affect it. How that would affect our mean, median, mode, all that stuff. So the first thing they're asking is to create a uniform distribution between 6 and 14. So what values would you have to add to this current data set in order to do that? Notice that 10 is the highest with a frequency of 4. So if I wanted everything to be uniform, what other values would I put in there? All right, so hopefully you listed all the values that I could tack on here to bring this to the top. So 3 6s, 3 7s, 2 8s, 1 9, 1 11, 2 12s, and 3 13s, and 3 14s. So I'm going to do that. I'm going to go quickly into my list, make sure I delete what was previously there. And I'm going to type those numbers in. So 6 6 6, 7 7 7, 8 8, 9 9. Oh, only 1 9. So 10 is up to 4, and 11, 2 12s, 3 13s, and then 3 14s. All right, let's go to stat, calc, one var stats. Now before I do this, I want you to make a prediction. If I make this a uniform distribution, is that going to affect my mean and my median? Are they going to change, stay the same, or how are they going to change? Get higher, lower? What do you think? All right, so let's check it out. So we can see that in this first situation for uniform, mean stays the same, and median is also going to stay the same. Oh, I just guessed that, right? Let's check it. Right, median is 10. Great. So I'm going to go back to my stack quickly and erase all those other ones, so I don't forget. All right, 6 over 6. Okay, good. It's an easy way to do this. Well, not easy. I wish I could just delete them all at once, but better than nothing. Okay. All right. Next, for number 2, they want us to skew to the right. So if I want my my graph to be skewed over to the right, I'm going to want it to trail off over to this right side. So I'm going to add a bunch of extra values here at the end to skew it off so that we see that the distribution continues over here, right? That tail that looks like it's sort of out of place is over to the right side. Okay, so let's see how that affects our data set. Okay, so from the beginning, we don't want that. Okay, so right here now I have my original data set ending with 14. And I'm going to add these extra dots, 15, 16, 17, 18. That's going to skew it over to the right. 15, 16, 17, 18. All right, let's see how that affects our graph. All right, we can see that our mean is now 11.1818. That's repeating. Now let's see what the median is. The median went up a little bit too. 10.5. All right, we can also notice that the mean is above the median, right? When we look at our normal distribution, right, the mean and the median were exactly the same. They were both 10, right? The mean was 10, and the median, they were both 10. Now we can see the mean is above the median. The median is 10.5. All right, let's see if there's a similar sort of reaction when we do the opposite. So 3, we're going to skew to the left, or a negative skew. So that means over towards the left side, we want to add more values to sort of stretch out this graph, give it a tail. So I'm going to add 5, 4, 3, 2. Okay, I'm going to delete the other values I put in there. 5, 4, 3, 2. All right, let's see how that is going to affect the mean and median. So let me let you take a guess first. Is the mean going to go up or down? Is the median going to go up or down? Which is going to be greater, the median or the mean, if I'm skewed to the left? All right, let's see. So the mean for number 3 is equal to 8.81 repeating. So the mean has gone down significantly. The median is also down to 9.5. However, if we think about how far away they are from their original values, the median was originally at 10, went up to 10.5, down to 9.5. So plus or minus half in each direction. The mean went up or down by 1.18 repeating, right? If we're at 10, we go up to 11.181, or we go down to 8.81 repeating, right? That's up or down plus or minus 1.11. So that's significantly more than the median changed. So the mean is much more susceptible to being skewed. So when I go back now to look at my skew here, if I were to track where about the median is, right, the median would probably be somewhere around here. The mean, however, is going to be affected by this skew, and the mean is also going to skew right or skew in the positive direction. Same idea here. If my median, let's say, is somewhere right there in the middle, my mean is going to be significantly skewed to the left, down. Mean and median are both what we call measures of central tendency. That means they measure where the middle of something is, what people should expect, a typical response. However, we can see that means can be far more variable. They change more. They can be altered by these skews, whereas a median is more likely to always be close to the center.